Hi, welcome to Knowledge Center. In this session, let me explain you about the timer registers which are used in microcontroller. So as you all know, in microcontroller 8051, we have two timers and we name it as timer 0 and timer 1. And the size of these timer registers is 16-bit. But microcontroller deals only with 8-bit registers. So what microcontroller will do now is, it may be a 16-bit timer register, but it is going to split it into two 8-bits. Like you can see here, if I consider timer 0, that timer 0 will be split into two 8-bits and we name it as TL0 and TH0. Means timer 0 lower bit, timer 0 higher bit. Lower bit means it is going to have an 8 bits, that is it is a lower byte. Okay, we call it as a lower byte and we call this as a higher byte. So timer 0 is split into timer 0 lower byte, timer 0 higher byte. So here you can see D0 to D7, this is lower byte, and D8 to D15, this is considered as a higher byte. Similarly, same kind you will have for timer 1. Timer 1, again it is split into two 8-bit register, that is TL1 and TH1. Timer 1 lower byte, timer 1 higher byte. D0 to D7, it will consider it as a lower byte and that is TL1 and TH1. All these are having its own register. Means whenever we want to give an input to a timer, we need to know the address of that timer registers. So here I have mentioned you the addresses of each register. If you want to give any input to TL0, right? That is timer 0 lower byte. The address of this timer 0 lower byte is 8AH and timer 0 lower byte so timer 0 lower byte is of 8AH, then timer 1 lower byte is of 8BH. Means address of this is 8AH, address of this is 8BH. Then again we come for a timer 0 higher byte. The timer 0 higher byte is of 8CH. This is an address, whereas similarly for timer 1 higher byte we have 8DH. So you just remember it easily, A, B, C, D, right? But they are not given it like this, 8A, 8B, 8C, 8D. They given it as 8A, 8B, then 8C, 8D. So that is how you can memorize the addresses of the timers. So by looking into this, you need to understand that it is dealing with an 8-bit data. Means microcontroller has not given one address for timer 0. It splits it into two and give that different address for two registers. So if it is 8A, 8B is given for timer 1 lower byte and 8C is given for this. Then again for timer 1 higher byte 8D. So these are the address of timer registers, and these timer registers are used to store the initial count in a timer. Now let me tell you what is the use of this timer in a microcontroller. See, timer in this sense, it is used to count, okay, or it is used to count the time. Generally in microcontroller, we are going to have oscillator. This is what we studied in architecture. So that oscillator will develop the pulses. It will generate the pulses like this. High, low bits will be there. So the timer what we are going to use, if you start the timer, this timer will start counting these pulses. The pulses which are developed in the microcontroller itself. That is developed by oscillator. Okay. So we can say that timer is a register which is going to count the pulses which are developed within the microcontroller. Okay, this is how you can define the timer. Okay, so timer is going to count the internal pulses. That is one statement in short we can give. And the same timer can be used as a counter. The same timer can also be used as counter. Then you need to understand now what is the difference between timer and counter. Right. So the counter in this sense, this is also going to count or start incrementing the numbers, but the counter means it's going to count the external pulse. This is not going to count the internal pulse. When I use this register to count the external pulse, then we name it as a counter instead of timer. Okay. So let me give an example that how we make it as a, means where we generally use it as a counter. See, if you are having an industry which is manufacturing some products, say it is manufacturing the soap, how many number of soaps have been developed So that is what I want to sense now. I want to count it. So I use a microcontroller IC, and there will be belt conveyor on which the soap products are placed. These soap products are made to pass like this. There will be a sensor. This sensor will sense the soap box, and whenever one soap box passes the sensor, this sensor will develop the pulse like this, and that pulse will be given to a pin, that is microcontroller, right? And the counter, now if I make it as a counter, this pulse will be read by the counter and it will be 1. If another soap box is passing over there, it will develop another pulse. This it will be given to the microcontroller and it will make the count as 2. So externally we are giving the pulse, not internally. That is why I am telling you that counter is nothing but the same register of timer is used as a counter when we make use of counting the external pulse. If you are counting the internal pulse, we call this register as a timer. If you are counting the external pulse, then we call it as a counter. I hope this is clear for you. Now let's see how to make this decision, that how that microcontroller will come to know that whether it should be used as a timer or it should be used as a counter. Okay, so for that we have two special registers which is to be studied to understand, wherein we can have the various modes of timers, and also we can also make that as a counter or a timer. So to make that decision, we have special registers. So before going to that special register, let me tell you one more thing, that how the inputs are given to registers, to timer. See, timer is nothing but, okay, I think I have explained you about the counter with example. Now let me explain you about the timer here. Where do we use the timer? The timer is used generally to create a delay. Means if you want to generate a square wave or some waveform, say I want to generate the waveform like this. So this can be generated using the timer registers. Let me tell you how. I'll just make the pulse as high. I'll write an instruction wherein I make it as high. Set bit. I'll make this high. And I hold that high for some duration. So this is how it will be. When you connect it to CRO, we get it like this. It will be holding that high position for some duration. Some duration in the sense some delay. Okay. So it means I will give in timer, I will give 0 0 initial count. I will give 0 0 and I will hold this high bit unless this becomes FFH. So it will count 0 0 1 2 3 4. Unless it becomes FFH, I will hold it. And after once it becomes FFH, I will clear it. Means the bit will be 0. So this delay will be applied same here. Again 0 will be hold for the, to completion of this count. Right. So this is how I can generate the pulse by using the timers, by using the delay. So this is what the delay I am going to use to generate some desired waveforms. Okay. So timer can be used to generate the delay, and using delay I can generate the pulses, or I can do some other task also. In this delay time I can do some other task. While the system is holding here, meanwhile I can execute some other subroutine program or something else. Okay. So that we'll understand when we go for programming of the timers. Now just understand the concepts and registers of it. Okay. So before going to the special registers, let me tell you how to give the data. I told you that you should give the 0 0 initial count to the timers. So very simple. Use basic register, that is move, and say if I want to give some data to timer 0 lower byte, TL0, hash 35H. So if I write like this, the data 35, the number 35 will be given to TL0. So in this register I will get 35. And after giving this register input to a register, if I start the timer start counting from 35, 36 like that. Okay. Same way you can use any other register to give the input. If you want to read the input, you can move it like this. Move R0 TL0H. So whatever the data I have in timer, that I can give it to the register R0. So same means as we are doing it for accumulator and registers to communicate, same way I can give the input to the timer, or I can read the input from the timers. I hope this portion is clear for you. Now let me explain you about the TMOD and TCON. So understand these two registers, because these two will help you to write a program. Let's look into the TMOD and TCON now. So here we go with the TMOD register. So in a timer, this TMOD plays an important role. TMOD, in short we call it as TMOD. Actually, it is timer mode register. This is also an 8-bit register. So in this 8-bit register, you can see here, we have same parameters what I have in these 4 bits. We have the same parameters in next 4 bits. So the nibble, 4 bits generally we call it as nibble. So the lower nibble, whatever the parameters I have here, the same parameters will be there in higher nibble also. Okay. So we reserve this for timer 0 and this higher nibble is reserved for timer 1. Okay. So first let me tell you what is this M0 and M1, and you concentrate on this explanation, because if you understand these 4 bits, then the same effect will be there on these 4 bits, but that is for timer 1. These 4 bits are giving an effect on timer 0. Okay. So M0, M1, these two stands for mode selection. Timers can be operated in 4 different modes, as I have mentioned here. Timer can be operated in 4 modes, that is mode 0, mode 1, mode 2, mode 3. Each mode is having its own special characters over there. Okay. But for microcontroller 8051, we are going to operate it in only 3 modes. That is timer 0, mode 0, mode 1, mode 2. Mode 3 we use it for 8052. So for explanation purpose, I will explain only these 3 modes now. Okay. So how to select this mode first of all, and what actually happens when we select that particular mode. See, if we select mode 0, if you want to select mode 0, you have to put 00 in M1 and M0. If I put 00 here, the timer will be operating in mode 0. So what is that mode 0? Mode 0 means it will be selecting 13-bit count, 13-bit timer. As I told you, timer register, that is earlier I have explained you, TL0, TH0, total it is 16-bit size. In that 16-bit size, I can make use of a 13-bit for timer counting. Just remaining 3 bits will be left. Only 13 bits can be used if it is in mode 0. So 13-bit means we use complete 8 bits of THX. THX in the sense, if it is TH0, timer 0, we use TH0 8-bit and remaining 5 bits are from TL0. If it is a timer 1, then TH1, TL1. That's why we generally mention it as X. Okay. So 13 bits are used to give the count and to make the count. If you want to use it as a 13-bit, you should make it as mode 0. So how to make mode 0? Put 00 in it. Next we may give this input 01. If you give 01 here, that is mode 1. Mode 1 is nothing but, you can see here, all 16 bits are used for timer. So all 16 bits can be used for timer, means I can count. If I use 16 bits for count timer, so I'll tell you what is the difference now. So if I say, let me change the marker. I think it's visible now. Say this is TL0, this is TH0. This is of 8-bit, this is of 8-bit. When I make it a mode 1, 16-bit timer in the sense, I can make use of all the 16 bits here. So the minimum value will be 00 and the maximum value will be all bits are high here and all bits are high. So if I make 8 bits as high, this data will be FF and this will be FF. It means I can start counting from 00 to FFFF. That is the statement here. Whereas if we go for a timer mode 0, only 13-bit can be used. We can make use of only 13-bit. So then what happens? It cannot count up to FFFF. Maximum count will be limited now. So we can count maximum. These 3 bits will be 0. Rest of the bits will be high. So if I write it like that, it will be something like this. We can count it up to 1 F F F. If you go for mode 0, you can count it up to 1 triple F. That is the maximum count if you go for a mode 0. If you go for a mode 1, the maximum count will be F F F F. Right. So compared to this mode 0, mode 1 is better because we can have more number of counts there. But if you go for mode 2, look at this. We can count only 8-bit. But we have one more extra word here, that is auto reload. Let me tell you what is that. So 8-bit in the sense, I am just making use of 8-bit here. Remaining 8-bit will be not used. So what would be the maximum count here? 0 to FF, because only 8-bit we can use. So I can make use of just count up from 00 to FF. Maximum I can count it up to FF. Right. So in this case what happens? Whatever the data we are going to give, the initial count, or it will count up to FF. Right. what is the use when we have a possibility of 16-bit timer here? Why we are going for 8-bit? Right, that may be the question you may have now. The very simple thing, when we go for an 8-bit or mode 2 conditions, here initial count. So initially, if you want to count from 0 0, I will put it in TL0. Right, and its copy will be stored in the other register, other 8-bit register. Once we complete the count, this data will be reloaded here. To understand this, I will take one example here. So what is the importance of mode 2? To understand that, let me give one example. So if you want to count from, I will erase this. I want to make a count from 0 0 to say 7F. I just want to make a count from 0 0 to 7FH. If we use this mode 1, then what happens is it will count from 0 0 and it reaches 7F. So after reaching the 7F, again it will go for an increment. When we go for an increment, means after this 7F, if you want to repeat the count, again what you need to get? I need to get this data. Right. Once you complete the count, maximum count, if you want to repeat that count again, I should get 0. After 7F, I should get 0. Right. But this cannot be done automatically. So in mode 1, what you need to do? Mode 1 and mode 0. In both the case, what we need to do is, you have to write a program or instructions in such a case that once the maximum count is over, after completion of this count, you have to reload this data by writing an instruction. You have to get this into timer by writing an instruction. So that you will understand while taking a programs. Okay. So you have to write an extra instructions or a program lines to reload the initial count once the maximum count is over. Okay. But when you go for this mode 2, this reloading will be done automatically, no need of writing any instruction. As if I tell you, once it completes the 7FH, it will not go for the next number. What happens? Once it completes the count, the initial count will be reloaded into that register, because this initial count is copied in TH. It has been copied in THX. Okay. So mode 2 will be used widely, because the auto reloading system is available in the mode 2, whereas in mode 0 and mode 1 we don't have that auto reloading system. This is about the modes, and while discussing about the programs, it will be very clear for you about these different modes. Okay. Now let me come to the other parts, that is C bar T. Okay. C/T bar we have. So C stands for counter, T stands for timer. So as I told you in the beginning of this session, that the same register can be used as a timer or a counter. So where should we make a decision? Yes, here we are making the decision. If this bit is 0, if I put 0 in this, then it will be selecting the register as a timer. TL0, TH0, whatever it is, it will be timer, because I am using timer. It means this, if I put 0 here, it will take it as timer. If I make this bit as 1, then it will be considered as a counter. So counter means it will be 1, timer means it is 0. That is why it is mentioned as T bar. It is inversion of that, invert of it. Okay. So whether I am going to make use of a register as a timer or a counter, that decision can be made at this particular bit. And whatever the input you give here, based on that, timer 0 will get affected, because this is completely reserved for timer 0. If you want to make timer 1 as a counter, then you should make this as high. So timer 1 will be acting as a counter now. Okay. I hope it is clear. Now gate. Let's see what is gate. So in short, I will tell you, in simple way I will explain you what is that gate is. So gate in this sense, actually in any microcontroller, we will have two possibilities of starting the timer. How to start the timer, right? To start the timer, we have two possibilities. One is by writing an instruction, like we can start the timer by writing set B TR0, set bit timer 0. So it will start the timer. If you want to stop the timer, we use clear TR0. So this is how we do it. So set B timer 0 in this sense, we have to start it. So this is instruction, means by writing an instruction I can start the timer. The other method is, there will be a hardware structure using which we can start the timer. So we have to decide whether we are going for a hardware or a software. And in microcontroller 8051 we have both. That means we can go by software method to start the timer. You can use the software method to start the timer, or you can use the hardware to start the timer, right? So when we have both options here, we have to make a decision now, right? So this gate will make that decision. If this bit is 0, if it is 0, it will select the software method of starting the timer. Means in program you have to write an instruction so that the timer will start. Okay. If it is 1, it will take it as a hardware method. Okay. So I hope it is clear now. The same explanation what I have done here, that will apply for timer 1 also. Right. Now let us understand this actual how to use these conditions here. By giving some examples, I will tell you. So now I want to use the timer 0 in mode 2. Okay. I want to use the timer 0 in mode 2. Okay. And I want to use it as a timer only, not counter. Right. So if that is the condition, what input should I give here? I want it in mode 2. So timer 0 in mode 2. So here what should I give? 1, 0 in these 2 bits. And I want it as a timer, not as a counter. So this bit will be 0. Here I should put 0. And always in microcontroller we prefer software gating, means software way of starting the timer. So by always it will be, it's better to have 0 here, right? So 0, 0, 1, 0. This is what the input I should give in this particular bits. And timer 1 we are not bothered about that. So let's give 0 here. All bits will be 0. So by writing this particular line, move TMOD, comma, hash. Here we, in these 4 bits I have 0, so I will put 0. In these 4 bits I have 0, 0, 1, 0. So what it means? 2. 2H. So if I put 0, 2H into TMOD, then what happens? The timer 0 will be selected in mode 2. And what is happening for timer 1? Timer 1 is also selected in mode 0 by default. If you don't give anything, here all bits will be 0. And if it is 0, it will be selected as a timer. If it is 0, it will be selected as a software method of starting the timer. And if these two are 0, it will be selected as mode 0. But now again we will have a control which timer I should start. There is another register, there will tell you which register will be used. Right. Now you should not by heart these numbers, you should understand. Based on our requirement, these numbers will change. Now say if I want timer 1 as mode 1 and timer 2 as mode 2, both things I want. So what number should I give here? Let me explain you. Timer 1, I want it in mode 1. Timer 0, I want it in mode 2. So just change the inputs in this particular bit. These two will be 0 because as I already told you, and mode 1. So mode 1 means what should I put here? 0, 1. Yes. Then mode 2 means this, let me keep it as it is. So here we have 1, here I have 2. So the only change is you should put this as a 1, 2H in TMOD. So the number what I am going to apply here, that totally depends upon what is the mode, in which mode you need to operate the timers. And now say I will take one more example here. I want timer 1 as mode 1 and timer 2 I want it as mode 2, but I want this to act as a counter. I want this to act as a counter. Okay. So then what happens? See, I will tell you the change. Now I want this as a counter, not as a timer. Okay. I want timer 1 in mode 2 and I want timer 0 in mode 1, and that too it should act as a counter now. So what should be the change here? Here what you need to do, you should put 1, 0 so that it will be in mode 2. Okay. Right. This is done. Now timer 0 here, this particular timer 0, I want to make use as a counter. So in this bit you should put it as 1 and mode 1. So you just make this as 0, 1. So now what happens? See, 0, 0, 1, 0. So this is 2, 0, 1, 0, 1. This is 5. So I should put the data here as 25H. So you cannot by heart these numbers. You never by heart that number. You just memorize. Remember this 8-bit register. Okay. And also I will tell you, if you just remember these 4 bits, same 4 bits will be there for the other higher nibble. So remember this, and based on our requirement, the bits will change. And after writing the bits, you just write that decimal number, that number in this line. Okay. This is how the TMOD register will be used. So finally I will tell you, TMOD is used to select the mode of timer or a counter, And also here we are making a decision that whether I am going to use it as a timer or a counter. And also one more decision we are making here, that is whether we are starting the timer by software or hardware method. I hope this is very clear for you. Now let's take on the other register, that is TCON. Let's look into that. So here we can see the TCON register. It's nothing but timer control register. So here we have a control over the timers. Means we can start the timer and also we can try to get a switch off the timer. So this is also an 8-bit register. As I have mentioned here, you can see the first 4 bits, that is the lower nibble. We mentioned this as lower nibble. These first 4 bits are reserved for interrupts. So these are going to affect with respect to the interrupts. About interrupts we are not yet discussed. So when we take up the interrupt topic, at that time I will recall this TCON register and I will explain these 4 bits, importance of these 4 bits for interrupt. Now let us not discuss about this. Now let us discuss only about the timer bits in this particular TCON register. So the higher 4 bits, that is higher nibble, is reserved for a timer registers. Okay. You can take this as a higher nibble. The higher nibble. So this is D0, means 0 bit, 1, 7, 2, 3 up to 7. So that is why it has been mentioned as MSB here. Okay. So higher nibble is reserved for timer. And here we have TR0, TF0. These two are reserved for timer 0. And TR1, TF1, those two are reserved for timer 1. Now let us understand what is this TR0 stands for and what actually it means, and what is TF0. If you understand these two, the same is for timer 1 also. The TR0 is nothing but, TR stands for timer run. Timer run control. This is timer 0 run, this is timer 1 run. Actually in short we can say that these two are the bits which are used to start the timer. If you want to start the timer 0, you have to make this particular bit high. So for example, say this is TCON 0 bit 1, 2, 3, 4. So I can write an instruction like this: set B TCON dot, what is the bit number? 4. So if I write TCON dot 4 set bit, means I am making this particular bit high. So if I make this as high, then only the timer will start. See, I'll tell you now. I will connect the link between the timer registers, TMOD and TCON. In timer registers, we will put the initial count. Okay. So if you want to start the counter from 0, 0, we have to put 0, 0 in the timer registers. Either it may be TL0, TH0, TL1 or TH1. And then which timer, which mode you need to operate, that we make a decision in TMOD. And how to start, whether software, hardware, that decision will be made in TMOD. Now as I told you in TMOD, if you don't put any data in the timers, in the registers, it will be 0, 0, right? But we have T0 and T1 in TMOD, right? We have 2 timers. So among those 2 timers, which one has to be started? That control we have in TCON. So if you make this as high, only timer 0 will start. And if this is low, then timer 1 will never start. Okay, so I have control of starting the timers. So we can start the timer 0 by making this as 1. You can start the timer 1 by making this as 1. So if you want to make this as 1, means if you want to start timer 1, then you have to write an instruction called set B TCON dot this bit number. See, we are starting the timer by writing an instruction. Because we used gate. In that TMOD we have a gate where we made 0. If the gate bit is 0, then we can start the timer using an instruction. If it was 1, then you cannot start it by writing an instruction. You have to give an input for a hardware structure. Okay, that will be complicated, so we are making it simple. We are using as instructions here, software. I hope you are understanding the connection between TMOD, TCON and the timer register. Now let's see what is this TF0. Okay, so TF0 means that is timer 0 overflow bit. Okay, TF0 stands for timer 0 overflow bit. This is going to be high. Initially it will be 0. Okay, by default all the bits will be 0. By default this bit will be 0, but this is going to become high once the count is completed. It means, say if I am starting the count from 0, 0 to FF. So once the maximum count is over, once it counts FF, and after FF again it will start from 0, 0. So once it counts the maximum number and then it goes for the next number, Here at that particular time, this bit is going to become 1 automatically. So we are not writing any instruction to make this bit as high. Now understand the difference between TR0 and TF0 is, here we have to make this bit as high to start the timer, but this bit is going to become high by CPU, by system itself. We are not going to do it, but we have to clear this bit. Once it becomes high, that is an indication for us that the count is completed. By looking into that, we have to take care what next has to be done. Okay, so we can clear this bit. We have to clear this bit manually by writing clear TCON dot this particular bit number, that is 5. Okay, same thing it will be there for timer 1. TR1 to start the timer 1, TF1 is just to indicate that the count has been completed, and that is done by the system itself. So after making it high, once it becomes high, we have to clear it by writing an instruction clear. Okay, so I hope this information about the timer registers is clear for you. If this is clear, then only you can write a program. So if you want to learn the programs regarding these timers, then you have to join for my channel there. So I will be giving the theoretical concept in these videos, which is available for everyone, but only members will have the beneficiary of programming. So if you want to understand the programs, then join to my channel, that is about microcontroller program concept. That channel you have to, that part of this channel you have to join, and you can enjoy the learning of programming there. Thank you.